So here what we're going to do is more factoring, okay? But it's stuff that, I don't know why they left these out. These are like the more fun ones, but it's okay. All right, so let's remind ourselves what factoring looks like. And I know you guys know this, but, okay, what can I factor out of this? 3x. No, in that one, 3x, right? I can factor out a 3x, and then what do I have left? X minus 2. Okay, so how did we get that x minus 2? What did you do mentally? You don't even think about it because it's such like common nature to you at this point. What did you do mentally? You divided by whatever it is that you are factoring out. If you factor out a 3x, you divided mentally each term by 3x, right? But it's so common, like you don't even have to think about it. So that's what we're going to do here now. So here I have negative 2x e to the x squared and then 6 e to the x squared. You see that from both of these you can factor out a negative 2, but there is also a common e to the x squared that you can factor out. So here we're going to factor out negative 2 e to the x squared. So now let's see what remains. This is like dividing by negative 2 e to the x squared. So first term we have x, right? Here we got plus 3, and that is the final answer. Okay? All right. Now, okay, so for this one, I'm going to give you a little, we're going to assume x is positive for this one, okay? So, and I'll tell you why. So what can I factor out of this? I can factor out an x squared. I'm sorry, no, I can't. I can factor out an x. But why can I only factor out an x and not an x squared? Because you only take the one with the smaller exponent, correct? So now I have e to the negative 4x and e to the negative x. Of those, if x is positive, which is the smaller exponent? Negative x or negative 4x? Negative 4x is the smaller, right? If x is 5, negative x is negative 5, negative 4x is negative 20, right? So e to the negative 4x. So now I'm dividing by x e to the negative 4x, x e to the negative 4x. So let's see what we have from the first term. I have a 5x, that's it, minus 2. Okay, what happens here? I'm dividing by the same base. That means I need to subtract the exponents, right? So it's going to be negative x minus 4x. Okay, so this is going to be x e to the negative 4x, 5x minus 2 e to the 3x. Minus, okay? Well, we're factoring out, it's like you're dividing by e to the negative x by e to the negative 4x. Same base, different exponent. You keep the base, subtract the exponents. Okay? All right, let's do this next one. So what do I factor out from here? I have some x plus 1s to the power of what? Which one do I take out? X plus 1 to the power of negative 3 over 2 times e to the x minus 2, right? Again, we're assuming that, the x is positive. All right, so let's see what we have. Okay. So let's see what we're going to have. So we're factoring out x plus 1, e to the negative 3 over 2, e to the x minus 2. So for the first one, I get 7. X plus 1, what's the exponent?
1.
So it's negative 1/2 minus 3 over 2. Okay? Go through that process. top exponent minus bottom exponent. And then the e's go away. So plus 2 now again I'm dividing by the same thing, right? X plus 1, e to the negative 3 over 2, that goes away. And then e to the x minus 2 is what I'm dividing by. So I'm going to get e to the power of x minus 2. Don't forget your like PEMDAS, like, you know, your order of operation stuff. Plus, here I have x plus 1 to the power of 1 minus negative 3 over 2. And then, oh, you know what? Sorry, I missed an x here. This last one should be e to the x. Right? So again, it's going to be the same thing. E to the, oh my God, that's such a lot of space. E to the x minus 2. How do you guys feel about that? So for each one, write down what you're dividing by. And then, look, same base, you have to subtract the exponents. If they're the same exponent, it goes away. Look at this one. Same base, I need to subtract the exponent. X minus x over 2. Here too, okay? X plus 1 to the power of 1 minus negative 3 over 2. X minus x over 2. Yeah.
Wait, so we factored out the x plus 1 to the negative 3 over 2?
Yeah.
The x minus 2?
Right.
Okay.
Okay? So now I have this times that. Okay, so now take a look at this one. Do you see how it has a negative exponent? Can it stay like that? No, it's got to move down, right? So look at what we're going to have here. We're going to have e to the x minus 2 over x plus 1 to the 3 over 2 times. Now I have 7 x times x plus 1, right? Plus 2 times e to the power of what? When you distribute, you just get a 2 plus x plus 1 to the power of what? 5 over 2 times e squared. And that is the final answer. Okay? And I know it looks silly, but when it shows up next year in calculus, this will literally be like step 6 of like 10, right? But we found that students were getting like stuck on that step, and it was like, you know, you couldn't get past it. So now we're teaching you from the beginning. Okay, go ahead and start on the next one, please. Figure out what you need to factor out. Okay, hang on. Let's please raise your hand when I ask you guys for the answer. I'll have you raise your hands. Okay.
Were we supposed to add x that final e?
Yeah.
Okay.
All right. Can somebody raise your hand if you think you know what to factor out? What to factor out? Imal?
3x to the negative 1.
Correct. Okay. So then, from the first term, we're just going to get a 1 because everything factors out. Oh my God, I'm so sorry. Right? Plus, so I factored out 3x e to the negative 1/2. Oh my God, why do I keep doing that? Okay. Now we're good. So I'm going to get 3 e to the what? 1. It's going to be 1/2 minus negative 1/2, which is a 1. Which, yeah, because we factored it out. So here, so take a look at what we have now. E to the negative 1/2 is a negative exponent, so it's got to move to the bottom. So in the numerator, I'm going to have 3x times this term, 1 plus 3e to the 1 over e to the 1/2. Okay? And it's okay that it looks that way. Yeah.
No.
Yeah?
Wait, for the exponent,
Uh-huh.
the last three e's,
Uh-huh.
I do negative 1/2.
Positive 1/2. So the top exponent, which is a half, minus the bottom exponent, which is negative a half. So half minus negative a half.
Oh. So
Top
okay.
minus bottom. So look, it can get a lot, right? When you're rushing, it's so easy to miss those. So what I do is, okay, top exponent minus, then I go to look to see what the bottom exponent is. Okay, let's do some of these bottom ones. Yes?
Wouldn't it should be like 1 plus 3? Like why do you have the 3e? Isn't there only 1e in the
Well, it's right, but it's still 3 times e to the 1, so you can't just dismiss it. Right? Here you still get 3e to the 1. Okay, so let's do this next one. We're going to factor out, yeah. 3e to the, what do you have?
I just had it on the side.
Oh, yeah. Okay, so here we're going to factor out 4 minus x to the 4 minus x squared to the negative half. So look, it helps to write down what you're factoring out. So I get 4 minus x squared to the power of what? 1. Yep. Minus x squared. And then what happens here? It's the same exponent, so they just divide out. So now, okay, this is what I have so far. So now, this first thing, it has a negative exponent, so it's got to move to the bottom. 1 over, you know what, let me write it down here. So this is going to be 1 over 4 minus x squared to the half times 4 minus x squared minus x squared. So that's going to be 4 minus 2x squared, yeah? Yes? All over that stuff underneath. And another way to write that is like this. Okay? So, you can leave the final answer in this form. Well, not in this form. It has to be 4 minus 2x. So you can leave it as the fraction times 4 minus 2x. You can write it like this, like I wrote. Or you can write it as 4 minus 2x squared over this to the power of 1/2. The correctness doesn't matter. Why does it matter, though, that you know that all of these things look the same? Because if this was, like if you are taking a multiple choice test, you don't know what format the final answer is going to look like. So you should know that, okay, all of these things are like synonymous. Okay?
So the problem with us, can we do it over root e?
Yes. Okay, let me do this one too, and then I'll take questions. So here we're going to factor out 2x plus 3 to the negative 1/3. Right? So let's just divide. So first I'm going to get, from the first term, I'm going to get a 1 minus 2x plus 3 to the power of 1/3 plus 1/3. So this will be, in the numerator, 1 minus 2x plus 3 to the 2/3 over that term. So 2x plus 3 to the 3rd, or the cube root of all that. All right? Okay, yes.
For e, do you want us to simplify the 4 minus 2x squared or no? Does that matter?
No, no, don't factor that anymore. Okay, let me do this one too. Okay, so now, okay, take a look at this one. Now we're going to go backwards, right? So what do you guys, okay, so if you have a to the b times a to the c, what is that? A to the b plus c. But now, would you be able to go backwards? If you had a to the b plus c, would you be able to go that way? Yeah. Of course you can. So that's what you have here, e to the x plus e to the 4. You can actually rewrite that as e to the x times e to the 4. This is also something that shows up in calculus, and then, you know, we never want to take time over there to do it. Okay? So look, go backwards. Isn't that the same? We're just now like undoing what we usually do. So how would we write this next one? E to the negative cosine x times e to the ln of 4. Now, this is going to be e to the negative cosine x times 4. So that is 4e to the negative cosine x. Okay? I just said you can't have any negative exponents. However, since you have a variable in there, you don't know, like depending on the variable, it could be positive or negative, so it's okay to have that. Okay, yes?
Should we put like e to the cosine x on the denominator?
No, so that's the thing. If there is a variable, then it's okay because depending on what the variable is, that's fine. Yes, quickly, yeah.
If it's meant to like assume that x was positive, would we then put it
Right.
on the bottom?
Well, no, because cosine varies, so you have. Okay, look at this one. Okay, e to the kt plus c. This is huge in calculus. It's everywhere. So let's do this one. It's going to be e to the kt times e to the c. Yes? So that's pretty much it. But then c is a constant, right? It tells you c is a constant. So what does e to the c look like? Isn't that also a constant? Right? So it's convention that we write constants first. Let's just do that just for fun. E to the c times e to the kt. Now look, you know how we said that's a constant? Well, if it's a constant, I can call it whatever I want. I could call it banana. I could even call it why not. And then it becomes why not e to the kt. So do you see where that comes from? It comes from like a calculation like this, which then like gets rewritten as that. So for this one, you don't really need to know that. You just need to know how to rewrite it in that form. Okay, so that's the lesson, right? That's where it comes from. It's because in the, it is pretty cool. That's where it comes from. Okay.
Yeah, I don't really understand.
Oh, yes. I don't know, it's on the... I can give you your test class right now. Okay.
Kinda, it's still gonna be there, but just gonna put yours on.
Jack is the one.
Yeah, oh yeah. Oh, she's like
Okay, if you got your test, you can go. I'm gonna say the same things, but yes, you can come back. Oh.
Oh, Miss Malikian?
Oh, yeah.
It's not graded yet.
No, not yet, because I only got them last night. Yeah. I don't have too much time. I do. Fridays we have. What is it? A quick question?
It's just I didn't understand why it wasn't working and I tried to.
Oh, okay. Maybe at bonus we can go over that.
Yeah, so I'll start from that.
Yep. Yep.
Thank you.
You're welcome. So this is going to be. So if you solve that, you don't get 3 over 5, right? You just get 3 over 5. If you solve this, you set that equal to 0, solve it, you just get 3 over negative 5, right? So this, you're welcome, bye guys. So this should have been x to the 5 plus 3. X to the 5 plus 3. It's in the notes if you look back in the notes. Okay. Oh.